In this video, you will learn how to detect multicollinearity in your dataset. Multicollinearity is a statistical concept where independent variables in a model are correlated among themselves. Remember, we are not saying independent variables are correlated with the target variable. We are saying independent variables are correlated among themselves, and we need to find those independent variables and remove from our model so that we can get a better accuracy and a better fit on our model. Let's import pandas as PD. Import seaborn as SNS. We will use seaborn to visualize our plot, or we can also use it for correlation metrics. Then I will import matplotlib. Import matplotlib.pyplot as plt, and then this magic line %matplotlib inline. Now I'm going to make one variable df, and in this I will save my data frame. I will read the CSV file pd.read_csv, and inside this I will type my CSV file name, which is train.csv. Let us look at the top 5 rows of a data frame. I will write df.head, and here in the output you will see we have this data frame. Here we have columns such as this MS subclass, MS zoning, lot frontage, and so on. And we have this target variable sale price, and rest of these variables are independent variables. Now let us also look at the shape of a data frame. I will write df.shape, and this will tell us the shape. So we have total 1460 rows and 81 columns. We can also check the data types, df.dtypes, and this will give us the data type of our column values. And now to look at the unique data types, we will just write here df.dtypes.unique. and why I'm doing this is because I want to get the unique data type. So here in this data frame we have 3 types of data. First is integer 64, second is object, and the third is float 64 type. Now to find the correlation among independent variables or the multicollinearity, we need to get all the variables which are numeric. So in our case we will select the data type having this integer 64 and float 64, because these are integer values, or they are numeric, not integers. Integers is different and float is different, so they are numeric values. So we want to get all these numeric columns, and we don't want to get this data type O. Here you will see O stand for this object because they are categorical columns. So now we are going to separate these numerical columns. I am going to make one variable num, and in this I'll make a list here, and in this I will type what data type columns I want. So I want columns whose data type is integer 64 and float 64. I'll just copy this from here and I'll paste it here. Then I'll copy this float 64 from here and I'll also paste it here. So now we want these 2 data types column from our data frame. Now next I'm going to make one variable num_vars. Now in this I will select the list of column names from our data frame whose data type is integer 64 and float 64. So I will write here list because I want to get the list of the column names, and inside this I will call our data frame df, and on this I will call the method select dtype. So this select dtype will select the data type which we want. So we want these 2 data types, and inside this I will pass one parameter include. So this parameter will ask us which data type we want to include. We want to include this integer 64 and float 64, and these 2 are saved in this list number. So I will pass here this number here, and now I will just execute our code. So here you will see in num_vars we will have the list of the columns whose data type is integer 64 and float 64. Now we are going to subset our data frame. So here you will see in our original data frame we have 81 columns. Now I'm going to subset it, and I will just keep these features in a data frame, because I just want these columns. I don't want the columns which are categorical. So now I'm going to subset our data frame. So I will call here this data frame df, then df, and what all columns I want to keep. I just want to keep these columns which are present in this variable numVars. So I'll copy this from here, and then I will just paste it here in this data frame, and I will just paste it. And now if I do the shape of this data frame df.shape, you will see that now we have just 38 columns instead of this 81 columns. Let us check if there are any missing values in our data frame. I will write df.isNA.sum, and this will give us the missing number of values column wise. So here in the output you will see we have missing values in this column lot frontage. There are 259 missing sample in this variable. Then we have missing value in this variable garage year built. So these two columns have some missing values, and now we are going to drop these two columns, as well as we will drop this ID columns because we don't need this column. Or we can just drop the missing values instead of dropping the column, or we can also even drop the column names. Let's do that. So I will write here df.drop_na, and then I will pass one parameter in place is equal to true. So now I'm not dropping the column names, I'm just dropping the missing values from these two columns, and I'll just execute the code. In place is equal to true means we want to perform this operation on this original data frame. That is why we pass this parameter in place is equal to true. And here it is saying a value is trying to be set on a copy of a slice from a data frame. You just have to ignore this. And now if I run this code again, I should get 0 here. So here you will see now I got 0 because now we have removed all the missing values from our data frame. So our data frame has no missing values now. And next, now we are going to find this correlation matrix. So we will find the correlation of each independent variable among themselves. And before doing that, I would like to tell you that we should always do this activity on the training data set. So we will split our data set into xtrain, xtest, ytrain, ytest, and then we will do this finding this multicollinearity in our xtrain, because to prevent overfitting we do not want to touch our xtest. That is why we will perform this on xtrain only. Now I'll separate this data frame into x and y. I will write here x, and in x I will have all the independent variables. I will write here df.iloc. I want all rows, and then I want columns starting from this index number 1. I don't want to include this ID column whose index is 0, and the index number of this MS subclass is 1. So I will write here I want all the columns starting from 1 up to. So now let me check the shape of our data frame. So I will write here df.shape. So there are 38 columns, so I want columns up to 37 for x, and for y I want last column df.iloc. I want all the rows. So for row we are typing this colon here, and I just want the last column, and to get the last column we have to type the index number, which is -1. So now we have x and y, and let me check in x what variables we have or what features we have. So we have this feature starting with MS subclass, that's correct, and we should not have this sale price. So, okay, so we have this EF sold, that's correct. So we have this x and y, we have prepared it, and now we are going to split this into xtrain test, ytrain test, and then we can start finding the multicollinearity. And to do the splitting, first I will import the train test split from scikit-learn. So I will write here from scikit-learn.model selection import train test split, and now I'll make xtrain, xtest, ytrain, y test, and then I will call this function train test split, and inside this I will pass x and y. My next parameter will be test size, which is going to be 0.3 or 30%. We will keep 30% for testing, and we will pass one more parameter, random state. This is a seed function. You can put any value here, but if you want your result to be same as mine, then you have to put 1 2 3. I'll execute my code. We are doing this splitting first because we want to avoid overfitting. That is why we will check this multicollinearity on this x train variable. Now I'm going to create a correlation matrix. So I will make one new variable, core matrix, and from this step we are starting finding this multicollinearity, and the first step is to find the correlation, and we will use this x train. So I will call this x train dot core, and now if I print this core matrix, you will see we will get a matrix here. So here you will see we have this rows and columns, and we have the correlation among these rows and columns. So for example, I'll show you how to interpret this correlation matrix. Here if I go up, so here first we have this variable ms subclass, and the correlation with this variable will always be 1. You will see that all the correlation will be 1 in this diagonal because they are the correlation among themselves. So for this lot frontage, with this lot frontage it will be 1. For lot area with lot area, this will be 1. And to check with other correlation, so the correlation of ms subclass with this lot frontage is minus 0.37, which is negative correlation, and then with ms subclass and this overall quality it is 0.01. then we have this here minus 0.01, 0.01, and so on. And here you will see some of the variables are having high correlation. For example, you see here this variable year remod add with this variable year built has a high correlation of 64%. And similarly we will see there are many other variables whose correlation will be high. So we have other variables as well, and you can explore this correlation matrix. But now you will observe that it is very difficult to go through this correlation matrix and find which variables are correlated among themselves, whose correlation is very high. So for that we will first we can create a function which will tell us which independent variables are highly correlated, and we can remove those features from our model. And let us also plot this. So here we have seen the matrix, and we can also plot this correlation using this heat map from SNS or the Seaborn. So I will type here SNS dot heat map, and inside this our correlation matrix variable. So now here you will see in the output, so we have the same correlation matrix, but now here we have visualized it. So we have heat map here, and here you will see, so we have this scaling also, and if the color is dark, you will see here, if the color is dark, then the correlation is in negative. If it is a little less dark, then the correlation is around 0, and if the color is very light, then the correlation is very high. So for all these colors where you will see this light color, these are the highly correlated variable, and these dark values, they are less correlated, and these black colors, they are negatively correlated. Now I'm going to define a function, and this function which will tell us which variable are correlated or have multicollinearity present in our correlation matrix. So I'll define one user defined function. So I'll write here define and the function name, which is correlation. This function will take two parameters. The first one is going to be DataFrame, and the second will be the threshold. So this threshold is very important. So this threshold tells us, suppose there are many variables which are correlated, and you want to set a threshold. You want to say that if two variables are having 70% correlation, I want to discard one variable and choose the other variable. So this threshold will work like that. You can put any number here, 60%, 70%, 80%, 90%, whatever is your criteria to decide there is a multicollinearity in your variable. Now in the next line I will make one blank empty set, and I will name that as correlated columns. This is going to be an empty set, and here I am calling set because I want to get the unique column names. And if you are aware about the set function will always give you unique elements. So that is why here I am calling this empty set, not list or tuple. Then in the next step I will make one more variable, which is correlation matrix, and I will call this data frame which we are passing here, and I will get the correlation of all the variables and save the result in this correlation matrix. Then I will print a for loop. I will run a for loop for I in range of length correlation matrix dot columns. So I'm going to run a for loop on the range of this column. So if there are 20 columns, so this for loop will run on that 20 columns. And then I will run one more for loop for j in range of I, and this for loop will run on this I. And then I will pass one condition, and the condition is if the absolute value, and inside this I will pass this correlation matrix, this matrix in which we have the correlated the correlation numbers. Then from this I will pass this ILOC, and I will see if in I and j, if it is greater than the threshold value. If the value of this I and j is greater than threshold value, then in that case I'll make one new column, new variable, which is column name, and then I will call this correlation matrix, and from that I will call columns, and I will select the first column, which is I, and then I will append this result in this correlated columns. So I will call this correlated columns, and then I will call the function add, and I will put this result, which is present in this column name, in this correlated columns, and then I will just return this correlated columns, which was an empty set. And now let me execute our code. So we have this correlation function which will tell us if two variables are correlated, then just give us one of them, because we want to keep only one variable, not both of them. Now let's call this correlation function. So I will call this correlation function, and then I will pass our xtrain. And now I will pass the threshold. I am saying that if two variables are having 0.7 or 70% of correlation, then just give me one out of those variables. So here you will see in the output, it says that these variables are highly correlated. So we have this first floor, SF, garage area, garage year built. This is TOT, RMS, AB, above grad. And if I change this value, let's say if I change this threshold 6, so I will have more variables now. So now you will see I have more variables because now I have lowered this threshold, and if I make it 0.8, then I will have very less variables here. And if I make it 0.9, I don't have any variable because no variables are having 90% correlation. So let's say I keep it 60. I'm saying that if two variables are having 60% correlation among themselves, then just give me a list of those variables. So these are the variables which are having high correlation. So we have this garage area, then we have this ground living area, and so on. Now what we are going to do, we are going to drop these variables from our xtrain and our xtest dataset, so that we don't have any multicollinearity present in our training dataset. So I will save this result in a new variable first. I will copy this from here. I'll make a new variable, correlation underscore feature. I'll paste it here. And now if I call this correlation feature, so we have these variables which are highly correlated, and we want to remove these variables from our xtrain and xtest dataset. Now let's drop it. So I will call this x underscore train dot drop, and I will pass one parameter labels. And which variables we want to drop? We want to drop all the variables which are present in this correlation features. So I'll just paste it here, and then I will give the axis. So these are columns, so I will type here 1. If there are any rows, then we have to type 0. For columns we have to type axis is equal to 1, and then one more parameter in place is equal to true, because we want to perform this operation on the original training data set. And before this, let me print the shape of xtrain.shape and also the xtest.shape. So our shape is 36 and 36, so we have around 36, so we have total 36 columns in both this train and test data set. And now we are going to drop these variables, and they are 1 2 3 4 5 6 7 8 and 9. So they have 9 variables, and I will perform the same operation on the x test also. So here, instead of train, I will just call x test here, and that's it. Now let me execute our code. Now if I run this line of code again, so we should get less number of columns here instead of 36. So now we have this 27 columns because we have dropped these 9 columns from our train and test data set. So this is how we remove the columns which are having multicollinearity. So these, if you keep these columns in your model, they will not help in prediction, because they are having the same relationship with the target as any other variable. So it is the best decision to remove these variables from your model. And once you have removed it, now you can build you can fit your model, and you will get a better result and also the better accuracy. So this tutorial was about how you can find the multicollinearity in your dataset and also how you can remove it. That's all for this tutorial. I'll see you in the next video. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.